The Earth is spherical. However, it is not spherical in which the way that you have been taught as a kid in school, how everybody has been taught. We're not living on a ball. We're living inside a ball. Convex versus concave, the concave Earth theory. I don't know if you've looked into it yet, but I want to encourage you to do that and to watch a lot of my content, and that's what I tell people about. And usually flat Earth is used from a divine point of view as a stepping stone for the people to break from that heliocentric mold, which is false. Stars are not millions of light years away. The sun is not very far away. Everything is close, and it's encased inside a sphere, which is the Earth. There's a celestial sphere in the middle of the Earth. Stars are tiny. Sun, moon, and planet are all orbiting inside the Earth. So look into my information. Keep in mind that within the flat Earth community, there are a lot of gatekeepers that want to keep you and others stagnant. There's a lot of impossibilities in flat Earth thinking. The star rotation in the southern hemisphere, for instance. And I've named many other possibilities. And so, but from a divine point of view, it is a way. The flat Earth movement is a way in which one can break free from the conventional heliocentric mindset that has permeated.
We do not like to believe that perhaps there is a whole world of things beyond our sensory perception, or outside of our ability to understand. We have to penetrate layer after layer of interpretation.
Force an extraordinary illusion in which the sensory information of the present is cancelled by immense knowledge derived from the
past. Foundations of the Earth. That's why there is an octagon in the center. And it can't be picked up with Canadian Meteor Orbit radar.
This tiny plastic boat is floating upside down in a layer of levitating liquid. It looks like a gravity-defying magic trick, but in this case the magic is in the science and the mathematics behind this counterintuitive new phenomenon. To start with, we need to explain how a layer of dense liquid can be suspended on a layer of less dense air. The answer is vigorous vertical shaking. This part isn't a newly discovered phenomenon, though it can be tricky to demonstrate. Take this dense blue liquid in a glass container. When you flip it upside down, it starts to fall due to gravity. It doesn't just move down all in one mass, though. Like paint falling down a wall, it starts to drip. The bottom surface bulges into droplets, which fall, displacing the air underneath until it ends up all in a layer at the bottom, as you'd expect. But if you place the container on a shaker set to a suitable frequency, something unusual happens. Once the blue liquid is fully upside down, it stops dripping. The vibrations prevent the droplets from forming and keep the whole bottom layer of the liquid nearly flat. And if the droplets can't form, the liquid can't fall. It's floating on a trapped cushion of air and contained by the glass on either side. It's compressing the air below it, but it can't displace it, so it hovers in place. While this was already known, researchers in France have been exploring another, even more counterintuitive effect of the shaking. When they place a boat or a light plastic ball at the bottom surface of the liquid, it floats in place, just like it would at the top surface. This is partly because the air pressure underneath the ball is quite high, since the air is being compressed by the weight of the liquid pressing down on it. But as you go up the liquid layer, the pressure decreases, as there's less water above it pushing down. This results in the ball or boat being pushed up by the pressure underneath. That is, until it reaches an equilibrium point, where that upwards force is balanced out by the downwards force of gravity, and it floats. This balance of forces is what causes buoyancy, and that's exactly what's happening here too, albeit upside down. But the most puzzling thing about this upside down floating effect is that it's stable. If you gently push or pull the boat, it'll bob back to its equilibrium position, just like its right side up counterpart does on the surface. The researchers mathematically modelled the forces involved, and sure enough, the figures predict this bizarre, stable reversed buoyancy. It may seem contradictory to all common sense, but the maths checks out. The effect does depend on the system being shaken hard enough though, and at the right frequency. If the vibrations get too small and gentle, the ball and the liquid will eventually fall. But get the shaking right, and that is how science can lead to a boat floating upside down on a levitating layer of liquid. Not with magic, but with maths.